Assalamu alaikum. First of all, I introduce myself. My name is Talha Yusuf and I am from BSBT. Bismillahirrahmanirrahim. My topic name is Protech. First of all, introduction of Protech. Protection from extreme environmental conditions has always been a critical requirement of textile products. The second point is protective textiles are a part of technical textiles that are used principally for their performance or functional characteristics rather than their aesthetic or decorative characteristics. The second point is need of protective textiles. As the name suggests, protective clothing and other textile materials are used to protect human beings' atmosphere from various natural industrial hazards. Some the possible environmental hazards are heat, cold, rain, snow, wind, ultraviolet radiations, abrasion, dust, microorganisms, radioactive radiations, static electricity, etc. Some prominent human industrial hazards are fire, flash, industrial chemicals, biohazards, high velocity projectiles, cutting or slashing by sharp objects, etc. We need optimum safety from all these hazards when we are in the vicinity of one or more of them. Thus, the need of protective textiles is there to safeguard us. The next point is property is required for protect lightweight and low bulk. The second point is high durability and dimensional stability. The third point is good handle and drape. The fourth point is low noise emission, water repellent, windproof and snow shedding, thermal insulating, UV resistant, air permeable, flame retardant, heat and melt resistance over low smoke emission, safety from radar spectrum. The next point is material used, fiber and uses. The first point is meta aramid, filter bags for hot gas, industrial protective clothing, racing driver suit, cargo covers, boat covers, fire hose, reinforcement. The second point is para aramid, body armor, tire cords, radiator hose, and brake shoes of racing cars, reinforced composites for aircraft, high-speed boat components. The third point is carbon, aircraft and space shuttle, automotive, medical implants, marine. The fourth point is glass, aircraft and aerospace, consumer goods, roofing tiles, corrosion resistant products used in highway overlay. The next point is classification of protective textiles. High temperature protective textiles, flame resistant protective textiles, chemical protective textiles, mechanical protective textiles, ballistic protective textiles, space suits, radiation protective textiles, clean room technology. So the next point is high temperature protective textiles like oven gloves, Nomex, Kevlar heat resistant gloves. A high temperature textile material is defined as a material which can be used above 200 degrees Celsius without decomposition and without losing its major physical properties. Although some fibers can be used for insulation and retain some strength even above 2000 degree Fahrenheit, they lose their textile characteristics at that temperature range. The thermal insulation provided by fibrous material is mainly due to the low thermal conductivity of the air entrapped in the fiber web. Thus, fibers, which are fine and dimensionally stable at working temperatures, are used in thermal protective clothing. Resistance to both flame and associated heat transfer through the garment is defined as thermal protection. Fiber used for high temperature protective textile. Aramid, meta and para. Pan or carbon. Glass, melamine, PBI, phenolic, polyacrylate, PTFE, polyamide. So the next point is flame retardant clothing like fire guard, fire entry suit, kill suit, proximity suit, and approach. Flame resistant fabrics are designed to resist ignition and self extinguish when ignited. It should also extinguish as soon as the ignition source is removed. Naturally thermostable or fire retardant agent treated fibers are used for obtaining fire protective function in textiles. Flame resistance in fabrics can be developed by two ways. One, by using inherent flame resistant materials and fibers. The second one is by giving FR treatments to fibers and fabrics. The next point is fibers used for FR textiles. Meta-aramid, para-aramid, modacrylic, polybenzimidazole, carbon, polyamide, F4 viscose, F4 cotton, F4 polyester. The next point is chemical protective textiles, chemical spray protection, chemical splash protection. The purpose of chemical protective clothing and equipment is to shield or isolate individuals from the chemical, physical, and biological hazards that may be encountered during hazardous materials operations. During chemical operations, it is not always apparent when exposure occurs. Chemical protective clothing is used mainly to prevent exposure during hazardous activities. These hazards can be grouped into categories such as chemical, thermal, nuclear, radiation like X-rays or UV, and biological hazards. The next point is levels of chemical protection. Vapor protective suit, liquid splash protective suit, sport function protective garment. Next point, mechanical protective textiles, cut resistant gloves, chainsaw clothing, puncture resistant gloves. The mechanical performance of fabrics is due to hybrid yarns in their interlacing. Textiles for mechanical protection can be manufactured from high strength textile fibers used alone or along with metallic fibers. MPTs have a personal protective function against different risks such as ballistic, blade cuts, fabric puncture, projection of fragments, knives, slashing, etc. Besides combined use of high performance materials such as glass fiber, HD polyethylene, or steel. The next point is ballistic protection like black plate pocket, movable lower back protection, adjustable side opening, side kidney protection, rifle bolster, detachable leg and shoulder protection, front plate pocket, modular load bearing webbing front and back, detachable groin protection. Ballistic protection is a class of protective clothing which aims at protecting the individuals from the bullets and steel fragments from hand-held weapons and exploding ammunitions. The basic idea of spreading the load over a large area is still applied. It is better to dissipate the energy of impact by deformation and breaking the protective material. Ballistic protection process is a complex phenomenon involving the transverse velocity propagation, tensile properties, and the fine structure. In the recent years, use of ultra-high modulus polyethylene fibers produced by gel spinning has been started in manufacturing of ballistic protective fabrics, bulletproof vest components. The next point is radiation protective textiles. Special gear can protect from some radiation. Alpha particles stopped by protective garments. Some beta particles penetrate the garments. Most gamma rays penetrate the radiation detection. Workers and officers working in nuclear plants and those working at and near the source of radioactive raw materials are prone to frequent exposure to alpha, beta, and gamma radiations. Radiation protection is also necessary for X-ray professionals, workers in cancer treatment centers, and other places subject to ionizing radiation. The second point is an important aspect of most radiation protection programs at nuclear facilities is the protection of workers from radioactive contamination while handling radioactive materials or working in radioactively contaminated environments. In this regard, protective clothing is used extensively to protect workers from contamination. UV protective textile, UV protective garments like sunburn. The aim of ultraviolet protective finish is to reduce a person's UV or exposure. Electromagnetic radiations of wavelengths between 150 and 400 Newton meter are termed as ultraviolet rays. Approximately 10% of sun's energy is in the form of ultraviolet radiations. Our atmosphere absorbs most of the noxious radiations emitted by the sun. Only 5% of the harmful radiations reach to the surface of the earth. UV absorbers such as benzotriazole and phenyl benzotriazole are able to absorb the damaging UV rays of sunlight. UV absorbers convert UV energy into harmless heat energy. The UV blocking capacity of a fiber can be improved by incorporating TiO2 into its structure. Thank you so much.